Alright, let's try and solve Advent of Go Day 3 in Crystal. I already took a look at the problem. It's, haven't started it yet though, but it's looking a little bit difficult. So basically what we gotta do is find all the numbers in here, and then if they're adjacent to a symbol, which means if there's any symbol in any of the spaces around the number, including diagonally, then that number gets counted as part of the sum. So we basically need to take the sum of all the numbers that are adjacent to any symbol. And a symbol is, I suppose, any of these, but not a period. A period does not count as a symbol. Alright, so that's basically the idea. Let's start off with the parsing around this. Actually, let's download the input first. AOC download. Should get the input there. And I never really use the puzzle, so I'm going to remove that. Okay. So let's just kind of take a peek at what our input looks like. Of course, a lot larger than the example, obviously. Oh, there it is. Okay. So we do have examples of numbers coming right at the beginning of the line there. Alright, let's give this a shot. So, first let's maybe take all the digits. I'm curious if I can reuse the scan that I've been using for the last couple exercises, so let's give that a try. That returns back a regex object, and I wonder if that regex object will tell me what, how far along on the string I am. So let's just say, let's just try and get the digits out first. So I'll say digits is equal to, or we'll just call numbers. Numbers is equal to input.split on new line. And then for each one of those, we're going to map over it and say do line end. There we go. All right, now for each line, let's try and do the scan thing. So we'll say line.scan, and let's scan for, well, I suppose we could do digits first, but what we really want to do is see any grouping of digits, any number of digits that's bound by either the beginning of the line or a period, end of the line or a period. But let's just take a look at all the digits first. Okay. And then let's just take the first one of these and print that out. Puts numbers. There we go. All right, let's see what that does. Crystal Day 3. All right. It's interesting the compile time is actually taking that long. I'm going to try reducing some of the computer resources here real quick. Close out of that one. Close out of these other applications. Okay. All right, so we're getting some regex match data here. So here's a 4, here's a 5, here's an 8, 6. Good, getting all the digits. Now, let's see if we can dig into what that regex match data has. Let's take a look at the standard library here. Say regex match data. There you go. Where'd it go? Where did the regex match data go? Oh, here's a struct. Okay. Regex match data is a type of the special variable, and the type returned by regex match string match encapsulates all the results of the regular expression match. All right. Returns the position of the next character after the match. Hasher inspect named match captures post match rematch size string 2A 2S. Okay. Well, this will give us, okay, the end, the position of the next character after the match. Is there a beginning? Yeah, there is a beginning and an end. Very cool. So let's say we said we want to get the beginning of it. So we'll map and we'll grab the beginning. Whoops, that's supposed to be a ampersand dot begin. All right. Let's just take a look and see what that gives us there. Okay, what am I doing here wrong? Wasn't that a thing? I thought that was a thing that we could do an ampersand. I'm sure I have an example of this in one of the other ones. Not there. There's one. Interesting, but that happens inside the parentheses. This is a thing that I'm a little confused about in the syntax here. Especially not coming from Ruby. Like maybe this makes more sense to people who are already doing Ruby or something. So I came from Elixir, which is inspired by Ruby, but alright, that's good. So we can see the beginning of 16, 17, 18, 22, 23, 24, 26, 27, 28. Very good. So now let's actually just get groups of digits. So let's say that we want a group of any number of them. And my regex skills are pretty bad, so let's do regex cheat sheet or something like that. Quantifiers, one or more. Example, plus. Okay, let's see what that does. It should be a smaller list now. Yep, there we go. Okay. So now we've got our beginning. We should be able to get the end as well, but we basically have all the information we need from that scan. Very cool. So let's make a data structure that looks like this. We're going to take a list of all the numbers. So this will be a list. And then it's going to be a hash with the, I guess, do we want to, no, we don't want to actually put a hash instead of an array here. We want to put, I suppose we could just store the regex as an array there. That's probably fine. Yeah, I think that's fine. All right, so that's what we'll do here. Instead of map, let's do a flat map. Put them all in one array. And then for each line, we're just going to map over it and stick that in the array. And then instead of the begin, actually, we can just leave that as the scan results there. Okay, so let's take a look at what that would look like, for instance. Let's just get maybe the first. No, we'll do everything. Yeah, and actually, let's just map and get the value of it as well. I think it's 0 or something like that. Get me the first part of it, and maybe a dot. Undefined method flat map. Okay, underscore flat map. I think I need a dot there. It's going to be pretty large, so. Alright, cool. So that should get us like all of our digits in there. Let's just a spot check. Take a look at the input and see if the last couple of them are 303 and 894 rather. Three or three, 894, and the first couple of them are 458 and 689. So we have 458, 689. Very good. Okay, very cool. So that gets us all of our numbers. Now let's get all of the symbols. And I think we can do something pretty simple here, because I think it's going to be as simple as saying, actually, you know what, we can just copy this over. I think we can do something as simple as saying not digit. So I think it's, what is not again? Not is, I think it's like a, well actually, not digit is just capital D, right? Not digit or a period. I think that's what we want. Comment out the numbers for now. Let's take a look at what kind of symbols we get. Symbols. Now at this point, we've already split on the new line. We're scanning the line. I don't think we have to worry about beginning or ending lines. Okay, so that is still getting the periods, and it's getting the digits. So it looks like it's pretty much the exact opposite of what we want. But it is getting the symbols, right? It's also getting symbols. So that's not what we want. We want something that's not a digit. So I thought that was what it was there. One character that is not a digit as defined by your engine's digit. So that should be correct. Alternation or operand. So actually, I think what I'm saying is, yeah, the digit is maybe knotted, but the period is not knotted. How do we say not in here? Capturing group, non-capturing group, more quantifiers, character classes, anchors. How do we say not? One character that is not X. So what if we just put the not period there? Well, no, that's just not going to work. Because that or really should be an and, right? So let's see how we do an and in our Boolean logic here. Okay, I think what we really should do is say not a digit or a period, and put the not in the front here. Nope, that's still not working. Although I somehow got the list really short there. Alright, what am I doing wrong here? Not a digit. So this is saying match a digit or a period. And this is saying not a digit or a period. Then match it. Let me remove that or there. No, that's just going to be digit followed by a period, right? That's fine. Okay, what's going on here? Not a digit or a period. Well, maybe let's do a regex tester and try and input for day 3. Okay, let's grab some section that has some symbols and some numbers and copy that into a regex tester here. regex101.com. Really bad at regex. Okay, so we want to match anything that is not a digit or a period. Oh, because I'm using the wrong not, right? Oh, okay. So I have to put it in square brackets, not a digit or a period. Hey, that's looking like what we want. Okay. Let's go back here. Put that in here. Okay, let's see if we get our symbols now. That looks like symbols. Excellent. All right, so for each one of these, we know what the beginning and the end is now. So we have the positions of all the numbers, and we have all the numbers, and we have the positions of all the symbols. Okay. Do we want to... So now we got to basically see which numbers are next to symbols. So we can iterate over all of our numbers, and we can check to see if there is a symbol in any one of those positions. So I think what we want is like kind of a lookup from an XY coordinate to whether or not there's a symbol there. Right? If not, yeah, maybe we can do that. So I think what we can try and do is let's maybe reduce this into a hash of, I think there's tuples in, yep, there's a tuple. And a tuple is written as these guys, okay. So we want to make a tuple of XY coordinates. Basically int 32, int 32. All right, let's start using some aliases here. Let's say that the position of something is an XY coordinate represented as a tuple. Position is equal to a tuple of int 32, int 32. Right. And then we're going to say that, actually, we'll start with that. So we'll say position, and then we're going to say symbol. But a symbol is just a, let's say a string, right? So we're going to reduce it into that. And then for each line, we're going to scan over it, and then we're going to take each one and add it to the hash there. All right. Now there's a couple ways to do this. I could do another reduce here, and then take all of its stuff and then merge it back into the original one. So let's see. This is, what do we want to call this thing that contains all of these symbols? We're going to say alias symbol map. Let's call it symbol map. It's kind of like a map of where all the symbols are. And we're going to just copy that bit. Symbol map. And paste that there. Cool. Now that we have a name for this thing, we're going to say that symbol map is our accumulator. All right. And so we could map over this or iterate over it, and then for each one smash it into the symbol map, or we could again reduce over this guy. And this is, I guess, also a symbol map, even though it's like a smaller version of it. It's just the one for the line, right? So we're going to reduce over the symbol map. And again, this is going to be line symbol map. Just to, you can probably use the same name there, but it'll be kind of easier to follow if we don't. So we'll just say this is going to be a symbol. For each one of those symbols, we're going to reduce do. Okay. I don't think it's reduce do, is it? I forgot. How do we do this in the other day? It is reduced to, okay. All right. So we're going to say that line symbols is equal to that. And then at the end of this, we're going to do symbol map dot merge, and we're going to do line symbols. Okay, and then for this one, we're going to say for each symbol, we want to create a tuple out of the xy, so we're going to do line symbol match dot merge, and then it's going to be a tuple of symbol dot. Well, the cool thing, I suppose, is symbols can only be one character, I presume. Right. So we don't have to worry about storing the beginning and ending separately. We just kind of need to know where they are. So beginning will be that. The y coordinate, we need to get the line number that we're on. So I suppose we need to do in our reducer, we also need to know what line we're on. Let's see how reduce works then. Sometimes reduce will have will also tell you what line you're on. Let's see, reduce, enumerable block. Okay, what other resources do we have in reduce here? Keep saying similar to enumerable reduce. Combines all the elements of the collection by applying a binary function specified by a block so as to reduce them to a single value. For each element in the collection, the block is passed as the equivalent value memo and the elements. The result becomes the new value for memo. At the end of the iteration, the final value of memo is return value for the method. The initial value for the accumulator is the first element in the collection. If the collection has only one element, that element is returned. Okay. So unfortunately, reduce doesn't give us the line number that we're on. So I think there's something called zip. Under arrays. It's all talking about zip files. Not looking for zip stuff. Okay. Sometimes it's called zip width, so we'll search for zip width. Zip width. Nope. Does Crystal not have a zip? Crystal Lang zip. Zip array. Oh, sometimes it's called with index. There we go. And then you get a tuple out, essentially. So I think we can do a split with index. That's going to give us the line number that we're on now. And this, instead of being, for each item, instead of this just being the line, we actually get line and line number. Okay. So we can do the tuple being line number, And that's actually just the key, and then the value finally is the symbol, which we don't actually care about, ironically. But we'll store it anyway. We don't care about it now, but you know, part 2 always gives us a twist. So maybe it'll become relevant. All right, let's see what that does. Okay, expected block parameter, not a tuple thing. Perhaps its destructuring is a little strange, and okay, didn't like that either. This time it was on this line. Expecting token ending parentheses, not arrow. Okay. So let's take a look at how tuples work. This is my first time using tuples here. So you can do a tuple literal. No issues there. Okay, here's what's going on. We gotta surround that whole thing with another set of curlies, I think. If you're nesting tuples or hashes, you must write them like this. Note the space after the first curly brace. Okay. Good to know. Undefined method with index for array string. Okay. Getting there. With index. They have a map with index. Do they not have just a with index on an array? Optimized version of enumeral map with index. Accepts an optional offset parameter. Map with index. Okay, I suppose I could do a map with index first. But really the only thing that we want to do with that, like, ultimately we want the reduce to take care of it. Right? So I'm kind of surprised that I couldn't just do with index there. What's its complaint here? It's saying undefined method with index for array string. Okay. Yeah. Okay. So let's do a map with index. But I think we can simply do essentially the identity. So given an argument, does that just work like that? Doesn't look like it does. Unterminated call. Map with index. This is probably another one of those things where the map actually has to be a block. What if we just did x, x? Is it happy with that? All right, I'm going to see if there's a better way of doing that at some point. Undefined method scan for char. So now we're on line 12. We're trying to scan the line. Okay, let's take a look at what we're actually working with here. Let's comment this out for a sec. Let's just say that we have symbol map and we're just going to say line here. Take a look at what is line and what is symbol map. Or more particularly, what is line? and we're going to just return back symbol map. There we go. All right, so that should spit out the line for each line. Okay. So I think it did actually spit out the whole line there. So is line not a tuple? Oh, you know what? It's not, right? Because this identity function is just returning back. It's not making use of the index. So let's just say that it has to be, I think I just put spaces there, a tuple of the line and the index. Okay, then we reduce, and then at this point we should have line and index. So let's say line 1 and see what that does. That should give us all the line numbers, hopefully. Sure does. 139, is there 139 lines in here? There sure are. Technically 140. Okay. So that's good. Now we can actually pull out the line and the line number. And let's just verify that we're still getting the line number. We are. Very cool. All right. So I think this should work now. Let's get rid of that and take a look at what sort of data structure we get here. Still not happy. Undefined local variable method line symbol match. Because it's not line symbol match, it's line symbol map. There we go. Cool, look at that. So we got a tuple of an XY coordinate and the symbol there. So let's see. This is saying at position 130, well, so let's start at the top. Maybe that'll be a little easier to hunt down. At position 64 on line 1, there is an asterisk. So position 64 on line 1. Oh, you know what? That's actually line 2, right? So this one right here. So this is position 64. Now it's actually showing up, I guess because this is 0 index, right? And I think the column there is 1 indexed. So if we start at the beginning here, yeah, column 1. So we go here, 64. There's a asterisk. Very cool. All right, so now we have our positions of all the symbols in a nice little map here, symbol map. Now we've got to iterate over all the numbers and check to see if any of the surrounding spaces contains a symbol, right? So for instance, let's put a little grid here. We've got the number 42. And we got some spaces around it. We have its beginning and the end. And we have what line number it's on. Right? Now actually we don't have what line number it's on at the moment. So let's fix that. When we do this flat map here, we're just storing the regex object. And we lose the positional information besides just the beginning and the end of where it is on. So how do we want to store this instead? I suppose we could say we could store it in the same sort of sort of structure here, we could say this is actually called a position map. And we can do the same sort of thing that we're doing with... Yeah, okay, so I guess we can kind of just copy this and make this the same for numbers now. But instead of just... Well, I suppose we don't need to store the beginning and the end. Because we know how long it is, right? And so let's replace any place where it says symbol map right now with number. Now this line numbers things is a little confusing. I'll just call this numbers, that'll be fine. And yeah, we'll shadow. It's okay. Maybe not the clearest, but we're going to do some shadowing there. This will be numbers now. Okay. Maybe we'll do the same thing here too. Symbol map. Symbols. Symbols. Okay. Yelling at me something here. What's it yelling at? Can't use variable name numbers inside assignment to variable numbers. Okay. So I can't do that then. Can't use variable name numbers inside assignment to variable numbers. Okay, we'll just stick with that. Let's take a look at the numbers now. Cool. All right, so let's take a look at the beginning of this and scope out how this is working out here. Oh, that was symbols. Must have skipped over numbers here. Okay, 16, 0. I should stop closing this. 16, 0, we get 4, 5, 8. There it is. 4, 5, 8. Okay. All right, so now let's iterate over numbers and grab its position. Look at the positions all around and check to see if there's a symbol in them. So what we're ultimately doing is, we'll call this part 1 finally. Part 1 is equal to numbers dot select do, and we're given a key and a value. So the key is going to be called position, and value is going to be number. Okay. So now we need to check to see if the, well, let's figure out surrounding. We're going to call surrounding is equal to position. Position will give us this like 16, 0, for instance. So I want to go from, oops, I didn't memorize anyway. 16, 0. And let's take a look at all the things that it should include. So that should now include, of course, we can't go less than 0. So let's maybe pick one that's not 16 0. Let's do this one. This 129, 57, 417. All right. So what should surrounding look like? Surrounding should include, we subtract 1, essentially, from both of those. So it goes from 1, 2, 8, 56, all the way to 1, well, then we take the length of that, right? It will be 3. Then we add that to 129. So we get 132, 56, right? So 128 to 132 is how many positions? That's 5, right? If we include both of them. Actually, it's 6 if we include both of them, right? So I think we just need to go to 133. Sorry, 131. 128, 129, 130, 131. It is 132. Okay, 132. That gives us 5. Then, of course, we include the ends, which are 128, 56, and 132. So this would be 129 would be the beginning of that. 130, 131, and 132 would be the next one. 132, 57. I said the wrong thing here. That should be 57. And then the last thing is just the same as this, right? But for 1, I'm doing something wrong here. This is not 126. This is 128. So this should all line up 128. That should now be 58. 132 is fine, and that's 58. Okay. So we need to check all of those things as surrounding. So we can say, maybe we can split up into smaller bits first. And we could say, it's kind of annoying that there's no, I don't think there's any for or array comprehension, list comprehension in Crystal. So if I want to get these tuples, I suppose, I mean, it'd be wasted effort to check the number itself to see if there's a symbol there. But it's a lot easier to just kind of go from this corner down to that corner, right? So we can say something along the lines of, let's do a for loop here. For, okay, how do we do for loops? Crystal Lang for loops. There's a while loop. You know what? There might actually be a for loop. I think it was something called each. Right, use an iterator instead. Okay, yeah. You can do a while loop, but so that's kind of the way we're supposed to do this. Okay. So I think we want to go from, now this position is a tuple, so we can actually write in here do x, y, and we can say from x minus 1 to x plus 1. I suppose we should start with y first. Doesn't really matter, I suppose. Do do y, and then inside of there do the same sort of thing, but with x now. So we're going for that whole block. Let's check to see if there's a symbol there. So we're going to check to see if symbols x, y is nil. So basically, if it exists, actually, you know what? What's better than that is there's something called haskey. Let me just look at the reference for that. Haskey on hash. There we go. Yep. So symbols dot has key So if it has it, then we want to return true. Otherwise, we want to return false for the select. So I think we can do an early return here. Let's see how we do return. Returning a value. The following example illustrates the use of an explicit and implicit return. Return symbols, return, ironically we're just going to say return true if true. It's kind of redundant, but we don't actually want to return false if it is false, essentially. So we only want to return if it's true. Return n if n even. Okay, return true. I forgot if true and false are supposed to be capitalized or not. I don't think they are. Okay, return true if symbols that has key. Otherwise, return false. Okay, let's do puts part 1, and we're going to just grab the values off of that. Okay, it's not liking this, probably because of that. Expecting identifier end, not do. Oh, I didn't say dot each. Okay. All right, where is it having that issue? Line 40? Uh-huh. Can't return from top level. Right, because we're not actually in a function. We're actually in a block. So we could create a little function. I don't think I've done that yet in one of these exercises. So let's create a little function here. We're going to say, how do we do that? Is it just def? Def, and we're going to call it check surrounding. We're going to give it the position. And the number. And then we're going to copy this over there. Okay, so now hopefully we can do the select and pass it to the function. No, I don't think. Okay, let's go back to what we had there, and let's just kind of fix this up. We just need to determine whether or not something's true. So we'll just say next to or adjacent to symbol is equal to false. Okay, and then if it does have a key, then we're going to say adjacent to symbol is equal to true. And then we're going to return adjacent to symbol. Gotta close off the if there. Am I doing ifs correctly? I think so. And what else do I need to do? Should be fine. Let's see what it thinks of that. Now you could be adjacent to more than one symbol, and this is going to check all of them. But we could say as soon as you find a space that has a symbol, then just jump out of there. But it seems like that's working. Let's kind of spot check that. So for instance, this number right here does not have a symbol next to it. The first one we see in this line that does is 720, right? Now here's already an issue. We're expecting to see 515 next, right? But the next one that we see is 895. If we go over here, 910 has it. 13 does not. 775 does not. 956 does not. 971 should, so we do have 971. All right, but we already see some examples of 515 should be included in here and it's not. 286 should be included in here and it's not. Okay. So I think, okay, so we're going from y minus 1 to y plus 1, and we're going from x minus 1 to x plus 2, or x plus 1. Does it perhaps not include that? Let's just try doing something like puts 1, 2, 3. Actually, you know what? I mean, this one right here would have given the answer, right? So dot each puts index does 1, 2, and 3. So it is inclusive, it looks like. But maybe we need to go one more because it's starting at 0. Let's give that a try. Because it looks like the two cases that that was an issue on. Well, 515, it's that bottom right corner. Same thing with 286, it's the bottom right corner. So maybe that will solve the problem. Let's give it a try. Okay. 197. Nope, that's already a problem. 197 should not be included unless there's another one in here. 720 gets included. 352 gets included now when it shouldn't be. .286 is not being included when it should be. So what's going on here? We're on the right path, I think. I think these positions are not quite... Oh, you know what it is? We didn't include the length of the number. That wasn't taken into effect. So that should affect the x position here. This should be x, go back to it being 1. I think 1 is correct. X plus number dot, I think it's size. And do we need to add the 1? I think we still need to add the 1. Okay, let's see what that does. $720 is correct. And then that's the first instance of it on the first line. 515, that's correct. 286 is correct. The next one we see is a 895 on the same line. Good. Okay, then we have 910. Yep. Then it has 956. Yep. 971. Yep. Looking good. All right. Keep closing that. Should just switch over here. All right, I think that's good. So we can just take the sum of it, but before we take the sum, these numbers actually have to be numbers. So do values dot map, convert it to integer, and then grab the sum. It's a big number. Let's see if it's correct. Not the right answer, too high. If you're stuck, make sure you're using the full input data. There are also some general tips about the about page. So that number was incorrect, and it was too high. Okay, let's see if we can figure out a different number. Let's make sure we didn't miss anything. two numbers are not part because they're not adjacent to a symbol. Every other number is adjacent to a symbol and so is a part number. Their sum is 4, 3, 6, 1. Engine schematic. Your puzzle input consists of a visual representation of the engine. Okay. So I think the first things I want to check is make sure that symbols is still giving us anything that's a valid symbol. There's no invalid symbols in the symbols thing. That's the first thing I want to check. Okay. Let's just do print symbols dot values. Okay. So just a visual inspection of this. Let's maybe join them together. Actually, you know what? Can we maybe make this into a set or say unique on it? Unique. Compact. Nope. Let's take a look at what sort of stuff they have in here. Fill, flatten, inspect, last, map, pop, preprint, product, push, reject, remaining, reverse, rotate, select, shift, shuffle size, skip, sort, 2A, transpose, truncate, unique. There's a unique. Cool. So unique. Suppose I could have just tried it. Alright, I just want to make sure that for array string, it is unique without the UE. Okay. Got a star, an ampersand, minus plus, hash, percent equals, slash, $sign, and ampersand. Okay. So we're not seeing anything that we shouldn't be seeing in symbols. So that's the first thing I want to check. Second thing we gotta check is make sure that all right, let's make a little test grid guy. Let's say that input is equal to dot dot dot. Well, let's make sure it doesn't grab anything that is out of bounds, right? So let's put a star there, dot 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 dot. And then let's do, we are 1 away from that. We'll say we're 1 away from that, and we are 1 away from that, and 1 away from that. Trim. Gotta move this up. So now if I do numbers on this, trim, it's a strip. Okay, that's fine. But now I actually want to see part 1 values. We'll do part 1. Okay, so it's grabbing 1. And it shouldn't be, right? Because there's nothing that's adjacent to 1 at the moment. Let's slowly get rid of dots and see if it still captures it. Okay, still does. Actually, let me double check. So this would be adjacent to this would be these guys all around it. So this is not adjacent, right? Still captures it. All right, so finally it's gone. Let's get rid of that and put that star back in. Okay, still nothing. Let's put a star back in this corner. Okay, we're good. Star back in that corner. All right, and finally back in that last corner. Okay, now that we've eliminated that incorrect pulling of that star, let's make sure that it still captures where it should be. So we'll put a plus there, and that should include it. Cool. Let's move the plus to this side. Okay, let's move the plus to this side. Okay, and let's do this last corner here. And then there's actually one more case that I want to just make sure. I want to make sure that these guys don't get caught either, because they are the same sort of diagonal away from the one there. That's a diagonal in that direction. That's a diagonal. So we'll go 1 over, 1 over, 1 over. Let's be 1 over, 1 over, 1 over. Okay. So dot. And let's remove that one. And let's just make sure that that doesn't get picked up. Okay. I think we're good now. So let's give that a try. Values dot map to I dot sum. Okay, that is a lower number now. Let's see if it's any better. That's the right one. Very cool. All right. We'll take a look at part 2. I may not solve it on the stream. I might take it offline, but let's take a look at what it is. The missing part, let's see, okay. Missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly two part numbers. Its gear ratio is a result of multiplying those two numbers together. This time you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again. So that's a gear because it's adjacent to 467 and to 35. In this schematic, there are two gears. The first is on the top left. It has part numbers 465 and 35, so its gear ratio is 16:345. The second gear is in the lower right because its gear ratio is 491490. So here's an example of a gear that isn't adjacent to 2, and it has to be exactly 2, right? So if it's more than 2, then it's not a gear. And when talking about gear ratio, it's multiplying the two numbers, right? Yep. Adding up all the gear ratios produces that number. Okay. Well, fortunately, I think most of the setup was already done in part 1, so I think we can give this a try on the stream here. So let's do this. Part 2. This time we actually want to do symbols.select. Right. And we can actually, we're going to need something similar to this as well, so I'll copy that over. We can first make sure that we're only doing anything that is star, right? So we could do a, well, I guess that's what the select is for. So we can say X, Y, and then we'll say symbol. And then we'll put an end to that. And we'll just copy that in there. Okay. So we need to check its surroundings and see if it's adjacent to a number. But unfortunately, the way that I stored the numbers, it's not as simple as this has key. It's not as simple as saying, is there a number there? Because that will only tell if a number starts. Its left digit, essentially, is in that position. But we also don't want to iterate over all of the symbols. And all the numbers. Okay. So, is it better to maybe iterate over the numbers and see if they're next to a star? No, I don't think so. All right. We'll iterate over the symbols. That's fine. So we're going to say adjacent to. So for each symbol, we need to check to see if it's adjacent to exactly 2. Adjacent to 2 numbers. Right. Okay, we're going to count how many adjacent numbers there are. We're going to take each symbol, we're going to say if symbol is equal to star, then we're going to continuing on with this. Else we return false, right? Now we want to see if, okay, if the symbol is a gear, then we need to check its position -1 plus 1, and then -1 plus 1 on the X side as well. All symbols are only 1 character long, so we don't need to know what size it is. And then we have to check to see if there's any number. Well, okay, so here's the idea. We have to not only check plus or minus the space, we also have to check any possibility of that, of length of digits. I think there's up to 3. Right. Let's do a Control F here and say D4 or D3. Plenty of those. Any 4s? Nope. Plenty of 2s. Plenty of 1s. 3s, but there's no 4s. Okay. Don't really like how I'm going about doing it this way, but I think what I'm going to do is we're actually going to check not just 1 back, but 3 back. And 3, well, it doesn't have to be 3 forward. And actually, we don't have to do it on the Y, we only have to do it on the X, right? So we're going to check 3 back to see if there's a number that starts further back but ends closer to the symbol. So here's the idea. We've got a gear, and we've got, let me put this in comments so it stops doing that. Then we've got a number, 1, 2, 3. Right. So we're looking 3 back to see if there's a number that starts there. Do we want to do that on every row, though, or do we only care about doing that on the top or bottom one? Because it could happen at the bottom too. 1, 2, 3. Now, it could be a 2-digit number that starts here, which is, we have to count. It could be a 1-digit number that starts there. Could be a 3-digit number. Okay, so that's those scenarios. If we're checking all the way back and say 1, 2, 3, that would be adjacent to that too. This would not be, right? So we actually do need to check next to it there. So let's say in the bottom case here, let's say there's a digit 1, 2, 3 that starts there, or that starts 1, 2, 3 there, or that starts 1, 2, 3 there. Those are all valid, but we don't have to worry about if it's 1, 2, 3 there, which means that we only have to check up to that square. So we don't have to add any more than 1 to that side. Same thing, we don't need to check more lines up and down because all the digits go horizontal. You don't have any vertical digits. So we only really have to add this extra check there. And then we have to check to make sure not only that there is a key there, but that the value of that, or the size of that string is large enough to reach to make it adjacent. Does that make sense? That's kind of long-winded. But essentially, we're going to say numbers.hasKey xy. That will tell us, is there a number that starts in there? And then we're going to check, well, okay, let's do, and, is that a thing? Regex and? Yep. And numbers x y. That will give us the string dot size. Okay, so basically we want to see that will give us the x position. We really only care about the x for this calculation. And numbers dot size, something along the lines of like minus x wait, okay, let me try and actually talk this one out. Let's say the size can be 1, 2, or 3, right? Size can be 1, 2, or 3. If it's of size 3, if size is 3 and x is well, actually, if size is 3, then we're already good. If size is any less than 3, right, a 3-digit number starting in any of these squares is going to be adjacent to the star. A 2-digit number may not necessarily be. So if size is 2 and x happens to be x minus 3, this is where we actually need to know the original position of x, y, so we can compare it to, are we adjacent to this? Yeah, we do need to know that. Okay. What do we want to do here? We're going to call this xy j and I. I, j, and that one be I, j. So we want to make sure that its size plus I is greater than or equal to x minus 1. Then we're going to say adjacent after having done this loop, we can just say that this is equal to 0, and we can just increment it. Adjacent numbers plus plus. I don't know if that's a thing. Probably not. There might be a plus equals. There is. Okay, adjacent numbers plus equals 1, and then after that we're going to say return, or we're just going to say adjacent. I can't type anymore. Adjacent symbols, adjacent numbers equals 2. Okay, that'll give us all the symbols. And that's just selecting them, though. I suppose instead of selecting it, we should really just calculate the gear ratios as we're going. But I kind of want to just see where we are right now. Okay, it's coming out part 1. And let's see how we're doing. Now, if we've done anything correctly, we should have a relatively shorter list of symbols. Okay, so we got a list is now empty. That's not good. Okay, well, all I'm saying is that the size plus 1. Oh, that's right, because we need to know the original position. Well, we are using the original position there, but we're going to say that, yeah, I plus the size is greater than or equal to. Let's comment this out for a second, and let's just make sure that we're seeing anything. Nothing. Okay. Now, numbers is a key value pair, isn't it? Yeah, it is. Okay. Let's just return true for now in here. So that should give us all of our gears. Nope, that's not. Why is it not? Maybe because I'm doing this equals thing incorrectly. Let's say puts star equals star. Let's just even do a sanity check there to make sure I'm using the right equals thing. Okay. So now let's put symbol out here and make sure that symbol is what I'm expecting it to be. Okay. So now let's say symbol equals asterisk. Okay, got a bunch of true and falses. Fine. So this is just saying return true. Oh, okay. It's not doing return true, right? This false is always overriding it. So I suppose we could just do an else. Because we can't do a return in here. Else false. Do that. Okay. Good. That gets us all the stars now. Now we're going to check to see if there are 2 adjacent numbers, but this isn't the correct adjacent numbers, I don't believe. And then let's do with that bit too. Okay, let's see what the size of this is. $382. Presumably it should be a little bit larger, or actually smaller. Whoops. If I don't have this additional bit there. Oh, you know what? No, it should be larger. $328. Looks like it didn't matter, huh? Okay, so this is saying find all the digits. Whoops, sorry. Yeah, check to see the number, starts in any of these positions, and if so, add 1 to it. But we also have to check to make sure that this thing is actually adjacent. What that means is that its size plus the x position must be greater than or equal to x, or x minus 1. Let's see what happens if I kind of play around with that condition there. If that gets any lower, x plus 1. There we go. So surprisingly, doesn't seem to make a huge difference there. Minus 2, 328. Okay, I think the correct one is minus 1. We're going to leave that there, but apparently it doesn't seem to matter a whole lot. So we could calculate it as we go, but for now, all I'm just going to do is do a dot keys dot map and take the tuple that is the x, y, and do x times y, and then do dot sum. Okay, that's a pretty large number. Could be correct. We shall see. Not the right answer. Too low. Wow. Okay. So this is not the right answer. It is too low. So playing around with this doesn't seem to do much of a difference. Let's take a look at some of the symbols that we're getting back, some of the gears, and let's just kind of spot check a few of them. Okay. So the first one is at 64. So I think it's this guy right here. This one is adjacent to exactly 2. So that's good. Okay. Then we have 105. This one's adjacent to exactly 2. Good. Then we have 4, 2. This guy. Adjacent to exactly 2. Then we have 99, 2. Is that this one? Yep. Again, adjacent to exactly 2. Then we have 122, 2. This one. Again, adjacent to exactly 2. Let's see if we can find one that's not adjacent to exactly 2. This one is not. Actually, it is adjacent to exactly 2 again. This one's not. So this one is on somewhere around 77.8. So we shouldn't be seeing a 77.8 anywhere. We see a 135.8 and a 38.8. Here's just the 38.8. Nope, that's not the one either. Oops, sorry. I'm on 6 or 5. I guess I'm looking at 7, I suppose, instead. 6. I kind of got lost here. Is there like a pretty print sort of thing? I don't know. Alright, well, let's see. We take the product of the two numbers. Currently, they're not actually integers. Oh, I'm actually just taking the positions. Right? No. Yeah, I am just taking the positions. I need to know what the two adjacent numbers actually are. Okay. Yeah. Okay, so we can't just do this map thing. That's just going in the wrong direction. Okay, so let's swap this out now. We're going to reduce now. And we're reducing starting at 0. And else we're just going to do... Okay, so now that we have this reduce, each item is going to be, or sum, there we go, sum starts at 0. We're going to return sum in the false condition. If adjacent numbers is equal to 2 at this point, we reset it each time, each symbol, then we increment it, and then we check to see if that's true. And then we do sum is equal to, nope, we actually now need to keep track of adjacent numbers. Okay. Of string, there we go. We're going to say adjacent numbers dot push numbers ij. If the size of that is equal to 2, we can actually make this a 2 integer and make that an int 32. Sum plus equals product of adjacent numbers okay. I think that's what we want. Undefined method plus for nil. Int 32 or nil. What could be nil in this case? You're saying some could be nil? So I don't think we really want to do it. If adjacent numbers that size is equal to 2, then we return sum plus adjacent numbers dot product. Else sum. And the problem with that sum plus thing was that it wasn't actually returning sum, and so sometimes the sum was being returned as nil. Alright, so that's a much larger number. It's possible that's correct. Let's give that a try. Not the right answer. Too low still. Wow. Alright. Well, I think we're closer than we were before, obviously, because previously we weren't even multiplying the correct two things together. So we're saying if adjacent number size is equal to 2, then add to the sum adjacent numbers dot product. Multiply the two of them and then add it to the sum. Let's do puts adjacent numbers here. Code completion is like completely broken right now. Just kind of annoying. Alright, let's take a look at some of the pairs that we should be getting back. And let's first verify that they all are pairs, right? Yep, they all are pairs. Very cool. And let's take a look at a few of them. We got a 720 and a 730. That's this pair right here. Then we got a 286 and a 798 right here. We got a 910 and a 555. We got a 638 and 1111 or 111. We got a 971 and a 124. Let's take a look at this one. We got an 8. Do we have that one? 971124 was the last one I saw. Then we got a 490. 490 and a 745. Where is that one? 490, 745. So are we missing one already? This one's missing, right? So that one is missing 846 and 176. Alright, let's figure out why that's missing. So we're checking again all the surrounding squares. And then we're checking a few back as well, right? We're checking a few back. So it's a good thing that we're not seeing that 97 there, because I think we're checking as far back as this square, right? Let's kind of copy over this little chunk here. Whoops, that's not what we want. Okay, so let's just kind of focus on this little chunk here. Okay. So we're looking back a little bit. We're looking back, of course, the plus and minus 1 on the y-axis. But we're also going back 1, 2, 3, and checking to see if something starts there. So this 9 does actually start there. So it's kind of a good thing that we're not getting that. Let's see if we can twiddle with this and get it to actually show up in that list there. Not seeing the 97 anywhere. Let's actually tweak this again, and we're just going to, I'm not going to put that, I'm just going to move that out to that side. And let's just grab like the first 10 of them, or 20. Oh, that's right. Okay, because we currently have like a... okay. We're doing the puts inside of here. That's how we're getting all of them. That's fine. That's fine. Okay, so we see some examples of things that are... Oh, this one has 3 around it. So let's actually put... okay, so we should be able to find that one. That one's actually this one, 97, 846, and 176. So this is an example of having 3 around it, but that's actually an incorrect because this one shouldn't be included. So if let's try and get rid of that one now. X minus 1. It's still there. Okay. So we're saying the number.size plus its x position must be greater than or equal to no, that's not right. I think I'm doing the math wrong on that. I need to be checking to make sure that this thing ends no, I guess that is right. Right. We take where it starts, add on its size, and that has to be greater than or equal to x. Okay, well that seemed to have gotten rid of that one. Do we still see 846 and 176? We do. That's good. Okay, well, I think we're getting there, but I think I may have to just do a little bit more tweaking with it. So I'm going to end the stream for right here, and hopefully we'll